Hello, this is Dr. Mears. Today we are going to be learning about functions. And the first question that we're going to start with is, what is a function? Well, the definition is it's a special type of relation. In mathematics, we have a rule for functions. Each input, x, must relate to one and only one output, y. No repeating x values with different y values. We're going to take a look at that today. Here's some examples. We have to determine whether each relation below is a function or not. I'm starting with just a real world problem. We're going to the movies. We have the number of adult movie tickets and the total cost. So is it a function? Well, let's set it up. What they're talking about is our input is the number of adult movies. A number of adult movie tickets. So number of tickets. That's the input. You tell them how many tickets you want, and what do you get out? You get out what you have to pay, which is the total cost. Now, when we go to the movies, let's say that we go with a friend or a relative. So we have two adults. So we have the number of tickets is 2. And the total cost, well, let's say that one ticket is $12. Let's just say, just for our example here. So if we need 2 of them, the total cost is going to be $24. Let's say if we needed 4 of them, we input 4 and we would get out an output of 48. Let's say we went back another time and we went with a friend again and we need 2 tickets. Now here's the thing, they're going to be $24. They're not going to change. That price is not going to change. So this is a function because each input will always get that same output. We put in 2, we get out 24. If we put 2 in again, we get out 24 again. If we put 4 in, we'll get out 48. So the inputs are attached to the same output. Okay, let's look at number 2. So I'm now defining inputs and outputs as x and y. So x is going to be your input and y is going to be your output. So what I first looked here for are repeated x values. If you don't see any repeated x values, it's a function. So let's look. We have 6, 8, 10, and 12. We have no repeats, so it's a function. Okay, number 3, let's look for repeated x values. 5, 5. Ooh, there's a repeated x value. Now here's the thing, it has to have the same output, the same y value. So let's look. Here we have input of 5 and an output of 20. Here we have an input of 5 and an output of 25. So this is not a function. The input of 5 has 2 different outputs. 20 and 25. So that's why it's not a function. All right, let's look at what we call mapping. And mapping just shows you which input, and now remember x is our input, so I'm going to write that, and y is our outputs. Which input is assigned to an output, so you follow the arrow. Again, we look for repeated x values, so 1, 2, 4, 6, 8. There are no repeated x values, and you can see here 1 is assigned to 2. 2 is assigned to 4. So it's very similar as ordered pairs here, but except it's just given to you in a different representation. So we have no repeated x values, definitely a function. And so each input, let's write like this, each input has one and only one, there's the bell, output. Now it's on my video and everybody's going to hear it. At least I'll know where everybody is in the video when I hear that sound. Okay, let's look at number 5. Again, we have a mapping. So what we're going to want to look for, there are no repeated x values here, but we do have the number 1 attached to 2 different outputs. 1 is attached to the number 2, and 1 is also attached to the number 6. So while our map doesn't have those repeated x values here, we see if we write it in ordered pairs, this 1 can't have 2 different outputs, so not a function. Okay, now here we have an equation, another representation. In this equation, this is actually linear. So how I know that it's linear is because my x value, my highest exponent of the x value is 1. So this x value has an exponent of 1, and this y has an exponent of 1. So that's how I could tell that it was linear. But regardless, if you don't remember if it's linear or not, how do you find out if it is a function or not? What you do is we have to input some x values and see what we get out for y. Can we get out 2 different y's? So we can just pick any number. You can pick the number 1 to input for x. So we're really going to input it. Y equals -3 times 1 plus 7. So I just substituted it in. Y equals -3 times 1 is -3 plus 7 is 4. So I input 1 and I got an output of 4. Okay, let's see. Let's try the number 2. Oops. So we're going to input or substitute in 2. And we are going to get out, that's 3 times 2 is -6 plus 7 is 1. 1. Okay, so here we see if we input 1, we substitute it in, we are always going to get 4. We input another number, we're going to get 1, which is we input 2, we got out 1. If we input 3, we're going to get out another number. So this is a function because there's no way that I can input 1 and not get 4, because this will always be the equation. So yes, function. Each input will always get out the same output. Each input will always have one output, which will be the same one every time. Okay. Number 7, we have y equals the square root of x. So again, let's substitute in some numbers. For this one, I'm going to try the number 4. So y equals the square root of 4. Now, what a square root means is it represents how many times, oh, sorry, not how many times. It represents what number times itself gives you 4. Let's write that down. What number times itself gives you 4. That's what this square root symbol is really saying or asking you. So what number times itself gives us 4? Well, you guys are going to say 2 times 2 is 4. So the answer could be 2. So 2 times 2 is 4. The square root of 4 is 2 because 2 times itself gives you 4. However, there is another number, and the other number is -2. So if we put in 4 and we take this square root and we multiply a -2 times another -2, we are going to get out +4. Right? Yes. So we could input a 4 and get out 2 different answers here. One is positive, one is negative. Same input, different outputs, not a function. Okay. Now the last couple are going to be about vertical line test. Now what we want to do here is we have this line. This is the one that we're going to examine as a function. As you can see, it's linear. And you know now that, there's the bell again. Yay! You now know that linear is a function. But let's look at the vertical line test. The vertical line test, or VLT, What it says is we're going to take a vertical line and we are going to scan this document with it. And when we scan this document with my now blue pen, if my blue pen hits more than 1 point on this line, it is not a function. So let's see, my blue pen is scanning this right here. It's only hitting 1 point. I move it over, I'm scanning again, it's only hitting 1 point. So every time I move my pen, it's only hitting my line once. So vertical line only hits graph once as I scan. It is a function. Yay! Okay, let's do the other two with the vertical line test. So here, again, I'm going to take my blue pen and I'm going to scan. This is called a parabola. And as you can see right here, it's only hitting 1 point. I scan it, only hitting 1 point, only hitting 1 point, only hitting 1 point. So only hitting 1 point. As vertical line passes through, it is a function. Okay, and my last one. Here we have number 10. We have a circle. So taking my vertical line, I'm scanning it. Uh-oh, you can clearly see that my vertical line is hitting both the top and the bottom of the circle. I'm hitting here and here. I'm hitting 2 points. That cannot happen. No. Vertical line hits 2 points at the same time. So not a function, because it hits here and it hits here. So if we look, we have an x value or an input of 1, and we have a y value or an output of 2. We also have another input of 1, but now we have an output of 8. And this same input with different outputs cannot happen. This is not a function. This isn't Dr. Mears, and I'm sorry if this is a little blurry. I'm looking at the screen right now, and it looks a little fuzzy, so I apologize for that, but this has been What is a Function, and good luck. Hope it helped.